In our last classification of matter video, we're going to look at some properties of matter and ways to separate different types of mixtures and compounds. So you'll remember our classification of matter breaks into two broad categories: substances and mixtures. Pure substance can either be an element or a combination of elements. And a mixture can either be heterogeneous, have layers, or homogeneous, no layers. Any one of these samples of matter in any of these categories, though, has a set of properties that can help you identify what kind of matter you have. The two broad categories of properties that we're going to look at are physical properties and chemical properties. So, starting with physical properties, a physical property is anything that can be measured without changing the composition in the material. You have to have the same chemical formula before and after a physical property is measured. Chemical property, on the other hand, is just the opposite. You can only observe a chemical property by changing the chemical nature of the substance. And so let's take a look at a list of properties here. So somewhere in your notes, you should make two columns: physical property and chemical property. You should look at this list and you should see if you can categorize them into one or the other. If you don't know what some of them mean, you should just Google them and see if you can find a meaning for those. And then pause the video and then put them into categories. So go ahead and pause the video now and do that. So hopefully you took time to actually engage in the exercise, and we're going to go through and look at all of these individually. So start with density. What is density? Well, density is mass over volume. You get the mass of something by putting it on a balance. If it's a regular solid, we can get the velocity by some the volume by some volume formula. So length times width times height. That kind of thing. And so none of those are going to change the chemical structure. A balance is not going to change the chemical structure of a substance. So density is going to be a physical property. Viscosity. Viscosity is the resistance to flow. And so something with a really high viscosity would be like honey, flows very slowly. Something with a low viscosity would be like motor oil. Motor oil is in fact engineered to have very low viscosities because you put it in your engine to keep engine parts from rubbing together. But watching the flow rate of a substance is not going to change its chemical nature, and so viscosity also going to be a physical property. Reactivity. So earlier in one of these videos we talked about sodium in water. If you put sodium in water, you get a fairly explosive reaction. YouTube is filled with videos, so if you want to go down a YouTube rabbit hole, just look up sodium in water. There are all kinds of versions of people freaking out over the response there. But what happens when you do that is the sodium, pure sodium metal, reacts with the water and produces what's called sodium hydroxide. So you get a chemical change in measuring whether or not something reacts with water. Hardness. Some of you may remember your geology unit. Some of you are convinced you never had a geology unit. Turns out you just don't remember it. But you were given a box of minerals and you were told all different properties that you could use to identify what kind of mineral you had, and one of them was hardness. So you're given a piece of glass, a penny, a nail, and you tried to see whether or not the mineral would scratch the glass, whether or not it could be scratched by the nail or the penny. And that was referred to as the hardness measurement of that mineral. And there's actually a scale called Mohs hardness scale, where the hardest mineral you can get, of course, is diamond. But scratching a piece of rock is not going to change its chemical structure, so hardness is going to be a physical property there. Flammability, so you can think about burning natural gas in a Bunsen burner. And so natural gas is methane CH4. When you combine it with oxygen in the air, you get a nice pretty flame, but then you also get carbon dioxide and water. So we are going back here. Flammability is going to be a chemical property there. Melting point. This one's a tricky one for a lot of people. So you are converting something from a solid to a liquid. We want to think about whether or not that's a physical property or a chemical property. Well, um, if you have solid ice, right, the chemical formula is H2O, and if we apply heat to that and mold it, we have liquid water. But that liquid water is still going to have the chemical formula H2O, so melting point is going to be a physical property. It is a property that helps you identify what chemical you have, because everything has, or not everything, but most substances have different melting points, and those melting points for pure substances can be used as identifiers. But the actual property, right, doesn't change the chemical formula. Malleability. If you looked up malleability, you found something like the ability to bend in shape. Metals are extremely malleable, whereas minerals are typically not. And so malleability, bending, and shaping is not going to change the chemical structure of things. Okay, so let's take a look at what these chemical and physical properties mean to our system of classification. Well, if you want to break things down into their simplest forms, you have to use different types of methods. So, breaking down heterogeneous mixtures into homogeneous mixtures requires physical processes. It's the separating of layers, but you're not changing chemical structures of anything. Likewise, with homogeneous mixtures, it's typically a physical process that will break things down into their individual compounds. So you could think like a homogeneous mixture of salt water. How do we get the compounds out of that? Well, you can boil the water off and then recondense it, and then you'd have H2O. And then the salt would be left behind in whatever container you boiled the water out of as a crystalline structure around the edge of the container. And so you'd have, if it was table salt, NaCl. So you can break a homogeneous mixture down into compounds through physical processes. To break compounds down into elements, though, require chemical processes. You're breaking, changing chemical bonds. And so it takes chemical processes to go from a compound to an element. So you can start with a heterogeneous mixture, break the layers down into separate homogeneous states, and then you can use physical processes to break those homogeneous mixtures into compounds, and then chemical processes, and eventually you could have things down into your base elements. A couple of pretty standard lab techniques for doing this. One is filtration. So if you want to take a heterogeneous mixture, like a suspension, and you want to break it down into its layers, you can use a funnel that has some kind of a screen or a filter paper in, and you can pour that liquid with the suspended particles through that filter paper. You can collect the liquid below, and then all of the solid would be trapped in that filter paper. Sometimes, if you look at that middle picture, we'll actually use an extra little bit of pull through that filter paper by using what's called a sidearm flask hooked to a vacuum pump. And so we'll create suction to pull the liquid through, and that is really useful if your suspension particles are really small. But that is separation by a physical property, which is particle size. Water molecules are much smaller than the suspension particles, and so they'll go through a filter, but the solid particles won't. Another good separation technique for mixtures is distillation. So if you have alcohol dissolved in water, the alcohol has a different boiling point than the water does. And so you can boil off the alcohol and collect it. And if you keep the temperature low enough, the alcohol vaporizes off, but the water doesn't. And so the point of that thermometer in there is to make sure your mixture is at a particular temperature. And as that alcohol goes up on that round bottom flask on the left, it will then condense in what's called a condensing tube, where you run cold water around the tube on the in a separate container, and what that creates is a much colder environment, and so the alcohol would condense and it would distill off into the container down over to the right. So that's a process of distillation where we're separating a homogeneous mixture by boiling point, because the bits in the mixture have different boiling points. And so these are various separation techniques that use physical properties to either separate heterogeneous mixtures into homogeneous mixtures or homogeneous mixtures into compounds. The last thing we want to look at here is some indicators of chemical change. So if we're going through chemical processes to separate compounds into elements, or compounds into smaller compounds, then typically through chemical reactions, we're going to get various indicators that something has taken place. So if you have two substances, you mix them together, and there's a noticeable change in temperature of the reaction container, that's a pretty good indication that some chemical process has taken place. If there's a change in color, if there is some change in smell or taste. This one is a little tricky. One, because you shouldn't be tasting anything you're making in the lab. And two, because some substances just smell bad to begin with. So you want to make sure that you are observing throughout the process and that this smell is some new thing that has been created there. The formation of what is called a precipitate, and this is usually a pretty good indicator of a chemical reaction. And a precipitate is what happens when you mix two solutions and you produce something in the reaction that's insoluble. And so it will actually come out of solution and you'll end up with a suspension, and those particles will settle out to the bottom. And so formation of a precipitate. You could also get gas formation from a mixture of, again, say two solutions. And that gas formation is going to produce bubbles. Any output of energy, so we already looked at change in temperature, but sometimes that energy comes in the form of producing light. And so the production of light is a really good indication of a chemical reaction. And then not all substances have the same density, or sometimes, again, you're producing gases, and if you are in a flexible container, those gases might cause that flexible container to expand. And so changes in volume are good indications that a chemical reaction has occurred. And so these are all good indicators that you're measuring some chemical property of a substance. And that concludes our discussion of classification of matter.